MethSL quadratics review problem 4. Let f of x equals 12x squared minus 12x plus 5. Express f of x in the form 2 times x minus h. Quantity squared minus k. Actually, I'm going to correct this in your review problem so this plus k so that it doesn't become more confusing. So the standard form for vertex form looks like this. Remember, a times x minus h squared plus k. H is the x coordinate, k is the y coordinate of the vertex. So there's a couple ways you could do this. The normal way is to complete the square. So how do you complete the square? Well, you have y equals 2x squared minus 12x plus 5. And the question you ask yourself is how can I make this into a perfect square? Okay, right now it's not a perfect square. If I found the roots or the zeros for this equation, the x-intercepts for this parabola, I would find two numbers that are not the same. I can put it into this form by completing the square and making the first part of this equation into a perfect square. What is a perfect, how can I make this into a perfect square? Well, I take the b term, negative 12, I divide it by 2, and I square it. That'll give me exactly the number I need to make a quadratic that is a perfect square. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36. Oops, I forgot to do one thing. Sorry about that. I need to factor out the 2, because there's a 2 here. I need to factor that out first. So I have 2x squared minus 6x. And I can just leave the 5 out, or I can put it in. I'll leave it out for now. So now I have the b of b that's negative 6. I divide it by 2, negative 3. I square it, I get plus 9. And then I also have to immediately subtract minus 9, because I cannot just like add plus 9 out of the blue. I need to add it and then subtract it, which is the same thing as adding 0, which is fine. Okay. So now I have this part, which is a perfect square. Okay. And so what I'm going to do is I'm going to change that into a perfect square. It's going to be that, right? So the green part factored is x minus 3 squared. Now the negative 9 we can't forget, we have to leave that. So we have plus 2 times negative 9. Remember the plus 2 here is going to be distributed with the minus 9 also. Okay, and then we have the plus 5 here. So now we have 2 times x minus 3 squared, and then we have this part that's a constant. So we have minus 9 times 2, which is negative 18, plus 5, which is negative 13. So we have just put that quadratic into vertex form. So we have x minus 3 and negative 13. So then it says write down the vertex of the graph of f. Well, once we put it in vertex form, we know that this 3 is the x-coordinate of the vertex, and this negative 13 is the y-coordinate of the vertex. So we can put 3, negative 13. Okay. Write down the equation of the axis of symmetry of the graph of f. We already have the vertex, and if the vertex, if we know it's 3, negative 13, then we also know something about the axis of symmetry. The axis of symmetry has to go through the vertex. So the axis of symmetry is this line here, and the axis of symmetry has the equation x equals 3. Okay, and then find the y-intercept of the graph of f. Okay, so we know this is the vertex here. Does it open up or open down? Well, we know that it opens up, right? Because the 2 is positive, so it kind of opens up kind of like this, probably. Okay. And let's see, we're not exactly sure where it crosses the y-axis. That's what they're asking. But if we look at the original equation, it's in the form ax squared plus bx plus c. When you have it in that form, you already know that the 5, the c term, is the y-intercept. So that's so we can see we drew this picture wrong. It actually goes up much higher. It's more like that, and it crosses the y-axis at plus 5. So one of the ways is you could say, hey, that's c. That's the y-intercept, like we discovered in investigation. Okay, so you could say, yeah, it's 5. The other way you could do it is you could just take either one of your equations, either this one or this one, and you substitute in x equals 0, because the y-intercept you find by saying x equals 0. Okay, and you just put x equals 0 into either one of these, and it's going to give you y equals 5. Okay, and then the other thing, the other equation is this one. So if you could also put x equals 0 into the vertex equation, and you would get 0 minus 3 squared minus 13. That would be equal to 18 minus 13, which is equal to 5. You get the same answer, right? Last of all, they say the x-intercepts of f can be written in this form. That looks strangely familiar. It looks kind of like the quadratic formula. It's not a coincidence. Basically, here you could take the fact that you have the standard form, 2x squared minus 12x plus 5, and you could write it. You can write down that a equals 2, b equals negative 12, c equals 5. And then you could just substitute these into the quadratic formula to find the x-intercepts. So that would be plus 12 plus or minus 144 minus 4 times 2 times 5 all over 2 times 2. So that would be equal to 12 plus or minus 144 minus 40 all over 4. So we're getting pretty close now. We get 12 plus or minus 144 minus 40 is 104, and underneath it's 4. So we could say P equals 12, right? Q equals 104, and R is 4. Okay. All right. So, and the other way you could do this is you could graph it on the calculator, assuming that you're allowed to use the calculator. So let me show you how to do this on the calculator. Since you could graph either the standard form, or you could graph the vertex form. Either way, you need to put y equals, and we'll clear that out. And we're going to put the equation here, 2x squared minus 12x plus 5. 2x squared minus 12x plus 5. And graph it. And we need to adjust the zoom. First thing, when you have a parabola that doesn't appear, you can put it on zoom standard, number 6 here. And it'll make a negative 10 to 10, negative 10 to 10 square here. And we'll see if that is good enough. Doesn't seem to show up. Okay, so now the parabola is coming out. And we don't see the bottom of it, so we need to adjust a little bit. If we were just down maybe like 5 or 10 more units, I'll go into window. I'll change y-min. Instead of negative 10, I'll put negative 20. Now we should be able to see the vertex. Yeah, we can. Okay, so now you can answer all kinds of questions about the parabola. Like, for example, they said, hey, put it in vertex form. Well, if you know the vertex, it's very easy to put in vertex form, and once you graph it on the calculator, you can find the vertex very easily. You use the function second calc minimum, because in this case the vertex is the minimum. So you just need to mark a couple places on the graph. First it says, where is your left bound limit? And let's say it's right here. I'm a little bit to the left of the vertex, which is what I want. Then it says, where's your right bound limit? Now I just put the cursor a little bit to the right of the vertex. Okay, and then what's your guess? It doesn't really matter what you put here, something in between the two. And it says, okay, your minimum is 2.999969, y equals negative 13. Actually, it does a algorithm to find the point, but sometimes it gets really close. It doesn't exactly get there. So 2.999969 is actually 3. Okay, so the point is 3 comma negative 13. Hey, what do you know? That's what we got when we found the vertex. So we confirm that the vertex is here. Once we find the vertex, we could write it in vertex form. And what else did they ask us for? They asked us for the axis symmetry, which we know because we just found the vertex. Okay. Then they say, what's the y-intercept? This is very easy to do on the calculator. We just press trace, and with trace, we can like move the cursor up and down, and it'll give you individual points, right? The problem is, how do we find exactly the y-intercept? One way to do that is we just type in 0. If we type in 0, it's going to make x equal to 0, which is the y-intercept. And it tells us that the y-intercept is 5, okay, which is exactly what we found before too. Okay, the other way you could do it is you could do second table, and it'll give you a table of points on the parabola, and you can see that x equals 0, y equals 5. So you can find the point this way also. Okay, so you can also see that the vertex is also here, 3 comma negative 13. Okay, and in this case, you can kind of see, because of the symmetry, negative 5, negative 5, negative 11, negative 11, negative 13 in the middle, you can also see from the table that this is the vertex. But sometimes you're not that lucky, because sometimes the vertex is not a whole number. Okay, and then how would you find the x-intercepts? Here you could use second calc, and then you would look for x-intercepts, which would be zeros. Oh, it's number 2 actually. And then you would say, okay, one of the x-intercepts is here. I'm going to set the left bound here, and then I'm going to go a little bit to the right, and then I'm going to guess, anywhere in between that range. And it tells me that one of the zeros is 0.450. Okay, so I'm going to put that here, 0.450. And the other one is on the other side here. So we could do that with second calc. 0. And then we could go all the way to the other side, because we don't want to find this 0 now. We want to find this 0. So we need to move the left bound to be to the left of this one. We're already close enough. We could just do enter here. And then the right bound, we need to go to the right side of the 0. And then our guess could be anything. And then it tells us that it's 5.55. Okay. And even though it says that y equals 2 times 10 to the negative 12, actually that's very, very, very close to 0, right? It's like 1/1,000,000,000. So yeah, that's supposed to be 0. So in this case, you found the x-intercepts in decimal, and it's not exactly what you need here, because they were sneaky. They told you to give it to them in the form that the quadratic formula gives you. So they were basically saying, hey, you got to do the quadratic formula here. We don't accept, calculator work for this problem. So I don't remember if this was a calculator problem or not, but if you were going to do it with calculator, you wouldn't get the numbers that you need here. You need to do it by hand.